In this module, we will look at atoms, ions, and bonds. Let's first look at matter. Chemistry is the study of matter and its transformation. So what we're looking at is matter and its properties, the changes that matter undergoes, and the energy associated with those changes. Matter is anything that has mass and occupies space. So that includes everything around us, from the air that we breathe, the food that we cook and eat, the cars we drive, all the way to the planets in the solar system. The smallest subunit of matter is an atom. It is composed of 3 subatomic particles. We have the protons, here, which are positively charged. We have the neutrons that do not carry a charge. And then there are the electrons that carry a negative charge. If all the atoms known to man have the same type of subatomic particles, that would be the protons, neutrons, and electrons, what makes one atom different from another? For example, why is helium a harmless gas, yet chlorine gas is toxic? The answer is in the number of protons and electrons and the arrangement of the electrons. Each element is defined by the number of protons, which is represented by the symbol Z. The protons and neutrons are located in the center of the atom in what is called the nucleus. The electrons, which are significantly smaller in size, are constantly whirling around the nucleus, creating an electron cloud, shown here in blue. There's no black dot to represent the electron because it's actually very difficult to pinpoint its location. So it's shown here as a blur. How much bigger is the diameter of the electron cloud compared to the nucleus? It's actually 100,000 times bigger. Let's put that into some perspective. Imagine the ball bearing held by this woman represents the nucleus, while the stadium behind her would represent the diameter of the electron cloud. Let's have a closer look at an atom. As I mentioned, electrons are in constant motion, so it's difficult to track its movement. In fact, the movement is quite complex, and so electrons are generally represented as an electron cloud. But for the sake of this module, the structure of an atom is going to be simplified by showing electrons sitting in fixed orbits around a nucleus. So this would represent a fixed orbit. An electron sitting in the outermost orbital would be interpreted as the surface of an electron cloud. Atoms have no charge. They are neutral because they contain the same number of protons and electrons. Atoms have an atomic number and a mass number associated to it. The atomic number, represented by the symbol Z, indicates the number of protons in the nucleus. For helium, it has 2 protons, here and here. And so the atomic number is 2. The mass number indicates the number of protons and neutrons in the nucleus. For helium, it has 2 protons and 2 neutrons, and so the mass number is equal to 4. And since the helium atom is neutral, it would imply that there are 2 electrons. Right? So the 2 negatively charged electrons would be canceled out by the 2 positively charged protons, making it neutral. The hydrogen atom is the simplest atom. It has an atomic number of 1 and a mass number of 1. This is because the nucleus contains only 1 proton. There are no neutrons. The hydrogen atom also has 1 electron, which is shown here in the outermost orbital. When a pure substance is made up of only atoms that have the same atomic number, the substance is described as an element. An element cannot be chemically broken down into simpler substances. About 99% of the mass of a human body is made up of just 6 elements. They are oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. All of these elements are important building blocks found in various substances in the body. Every element known to man is found in the periodic table. They are represented by an atomic symbol and arranged in order of the atomic number. The elements are organized based on their chemical properties. Elements with similar properties are grouped into the same column. Here are a few more well-known groups. There is the alkali metals. They are located in the first column on the left side of the periodic table. These metals are incredibly reactive, especially in water. Then there are the halogens. These are found in the second column from the right side of the periodic table. These elements are not metals, but are very reactive as well. On the other end of the spectrum, there are the noble gases. These are found in the column farthest to the right. These elements are the least reactive, and in some cases, not reactive at all. The periodic table can be broadly categorized into three main groups. There are the metals, the nonmetals, and the metalloids. However, we will mainly focus on the first two types. The metals and the nonmetals are separated by a diagonal line which can be referred to as a staircase. The metals are the elements to the left of the staircase, and the nonmetals are the elements to the right of the staircase. For hydrogen, though, even though it's found on the left side of the periodic table, it's still considered a nonmetal. Inside the atoms, electrons are found in orbitals, and these orbitals make up the electron cloud. The orbitals are arranged in an increasing order of energy, where electrons that are further away from the nucleus are occupying orbitals with higher energy. The lowest energy level orbital is found closest to the nucleus. It can hold a maximum of 2 electrons. All the other orbitals can hold up to 8 electrons. This is an important property as it will dictate the reactivity of an atom. The outermost energy level orbital is referred to as the valence shell. You can picture it as the atom's surface. As I mentioned earlier, it would be the outer edge of the electron cloud. When the valence shell is filled with the maximum number of electrons, then the atom is stable and will not readily react with other atoms. We can describe the atom as being happy when it's stable. On the other hand, if the valence shell is not full, the atom will react with another atom in order to fill their valence shell and become stable. Here we have a hydrogen atom. It has 1 electron sitting in its lowest energy orbital, but the orbital is also considered the atom's valence shell. And since there's room for 1 more electron, the hydrogen atom is actually quite reactive. Noble gases have their outermost valence shell full, and so they are stable and happy. They actually don't see a need for change. Noble gases are sometimes referred to as an inert gas because they are unreactive. Here we have a neon atom. It has an atomic number of 10, so there are 10 protons in the nucleus. There are also 10 electrons. 2 of the electrons are sitting in the lowest energy orbital, and the remaining 8 electrons are sitting in its valence shell. Since the valence shell is full, the neon atom is unreactive and very stable. It actually does not need any more electrons. Let's have a look at ions. Elements that do not have full valence shells are reactive. The atoms will gain, lose, or share electrons in order to fill their valence shells and become stable. When atoms gain or lose electrons, then the number of electrons will not be the same as the number of protons. When this happens, an ion is formed. Cations are ions that are positively charged, and it's the metals that will lose electrons. Anions are ions that are negatively charged, and it's the nonmetals that will gain electrons. When an atom loses electrons, a cation is formed and it will have a positive charge. This is because there are more protons than electrons. Each electron lost will result in an increase in the positive charge of the ion. Here we have a sodium atom, which is a metal. It has 11 protons and 11 electrons. The 11th electron is sitting all by itself in the valence shell. Since the valence shell prefers to have 8 electrons, rather than trying to acquire 7 more electrons to fill its valence shell and become stable, it would rather lose 1 electron. This way, the second orbital becomes the valence shell. The sodium ion now has 11 protons and 10 electrons, but the valence shell is full with 8 electrons, making the ion stable and happy. Since there's 1 less electron, the electron cloud actually shrinks and becomes smaller. The arrangement of electrons in the sodium ion actually resembles that of the neon atom, which is a stable noble gas. Because there's 1 extra proton compared to the number of electrons, the sodium ion will carry a positive 1 charge. Before we move on, remember that cations are formed when metals lose electrons. When an atom gains electrons, an anion is formed, and it'll have a negative charge because there will be more electrons than protons. Each electron gained will result in an increase in the negative charge of the ion. Here we have a chlorine atom. It's a nonmetal. It has 17 protons and 17 electrons. The valence shell has 7 electrons, with room for 1 more electron in order to fill the orbital. In this case, the chlorine atom will want to gain 1 more electron from another atom. When this happens, the chlorine ion will have 17 protons and 18 electrons, with the valence shell full with 8 electrons. This way, the ion will be stable and happy. With the extra electron, the electron cloud will become larger. The arrangement of electrons in the chlorine ion actually resembles that of the argon atom, and that is a noble gas which is known to be stable. Because there is 1 extra electron compared to the number of protons, the chlorine ion will carry a negative 1 charge. Remember that anions are formed when nonmetals gain electrons. Now that we understand what atoms and ions are, let's have a look at how chemical bonds are formed. Chemical bonds bring atoms together to create molecules or compounds of various sizes, either through the transfer of electrons from one atom to another or the sharing of electrons between atoms. There are 2 types of bonds that we will focus on. There is the ionic bond, used to create salt crystals such as the one here for calcium fluoride. And then there are covalent bonds. These are found in molecules such as oxygen and water. Both of these types of bonds are very strong and really difficult to break. We will first look at ionic bonds. Ionic bonds are formed between 2 oppositely charged ions through electrostatic attraction. Generally, it's between a positively charged cation and a negatively charged anion. If we think back to atoms, electrons are found outside of the nucleus. Sometimes the electrons can be quite far away from the nucleus. If they are far enough, the electrons can be attracted to the nucleus in a neighboring atom. Here in this picture, you can see that the electron clouds are distorted. They're more spread out. And this is because the electron in one atom is being pulled towards the proton in a neighboring atom. If the electrons that are being pulled get close enough to the nucleus of the neighboring atom, then the electron can be transferred over. So here, this electron, when it gets close enough, it can actually be transferred over to this atom, and the result are the formation of ions. The atom on the left, here, has lost 1 electron, and as a result, it becomes positively charged, and the electron cloud shrinks. The atom on the right started off with 1 electron, but now, because it's gained 1 electron, it is now negatively charged and has a larger electron cloud. Since the 2 ions are oppositely charged, they will be attracted to one another, and this is how an ionic bond is created. As I mentioned earlier, an atom can lose or gain electrons in order to achieve stability. Now, what an atom does depends on what kind of element it is. Metals will lose electrons and become cations. The example we looked at earlier was the sodium atom. Here, once it loses that one lone electron in the outermost orbital, then it'll be left with orbitals that are completely occupied, making the sodium ion stable. On the other hand, if the element is a nonmetal, then it'll gain electrons and become an anion. Here we have an example of a fluorine atom. It's missing just one more electron in its valence shell. Once it gains that electron, then it'll be stable. When the sodium and fluorine come together, the sodium atom can transfer its one electron to the fluorine atom. By doing so, the sodium and fluorine ions are now both stable because their outermost valence shell are full. And since they are oppositely charged, they will attract one another, creating an ionic bond. A general rule of thumb is that ionic bonds are formed between a metal cation with a nonmetal anion. And when there is at least two different elements in a substance, we can classify it as a compound. Simple ionic compounds always include a metal and a nonmetal. Much like the example we just saw, an ionic bond can also be created by having sodium atoms transfer an electron to chlorine atoms. The result is a sodium chloride ionic compound, also known as table salt. When a large number of ions pack closely together, crystals can form of various sizes and shapes. For sodium chloride, when the ions come together, they create these really cool cube-shaped crystals. For more information on ionic bonds, which includes interactive animations and exercises, check out the following tutorial. Now, let's move on to covalent bonds. Covalent bonds are created when atoms share electrons with other atoms in order to complete their valence shells. When covalent bonds are used to hold together atoms of one or more elements, a molecule is formed. Here we have an example of two chlorine atoms. They each have 7 electrons in their valence shell. They are both looking for one more electron. So if they share an electron with one another, they are able to complete their valence shell and become stable. The sharing of a pair of electrons is how a covalent bond is formed. When you see a line between two atoms, it represents a covalent bond with 2 electrons being shared. Here we have 2 chlorine atoms that have come together to create a chlorine molecule. Oxygen atoms have 6 valence electrons. They actually need 2 more electrons to become stable. Rather than sharing 1 electron with each other, they're going to need to share 2 electrons with each other. With the 4 electrons, 2 covalent bonds will be formed. And this is how an oxygen molecule is created. Covalent bonds are always formed between non-metal atoms. This is how you can tell the difference between a covalent bond and an ionic bond. Remember that ionic bonds always involve a metal. Here's an example of 2 hydrogen atoms sharing a pair of electrons. The result is a single covalent bond in the hydrogen molecule. Now, a molecule can also have more than one element. Carbon dioxide is formed from a carbon atom sharing 4 pairs of electrons with 2 oxygen atoms. And so the atoms are held together with 2 double covalent bonds. For more information on covalent bonds, including interactive animations and exercises, check out the following tutorial. In the case of hydrogen, you may notice that it's sitting in the first column. It falls into the same group as the alkali metals. However, hydrogen is not a metal. It is a nonmetal and is able to form both ionic and covalent bonds. When hydrogen is bonded to a metal, then an ionic bond has been created. The hydrogen has gained one electron and becomes an anion with a -1 charge. When hydrogen is bonded to a nonmetal, then a covalent bond has been created where a pair of electrons are being shared. However, there is an exception where hydrogen atoms that are covalently bonded in a molecule can be released as a hydrogen cation with a +1 charge. This exception occurs with hydrogen atoms in acid molecules under particular conditions. This is going to be explained further in a module on molecular behaviors. So in summary, an atom can have 3 types of particles. There are the protons, neutrons, and electrons. The protons and neutrons are found in the nucleus, which is really small, and the electrons are found in the electron cloud. The elements in the periodic table are organized based on the atomic number, Z. Z represents the number of protons in the atom. The mass number is the sum of protons and neutrons. When atoms gain or lose electrons, then ions are formed. Generally, metals lose electrons and become cations, which are positively charged since there are more protons than electrons. Nonmetals gain electrons and become anions, which are negatively charged as there are less protons than electrons. Lastly, there are 2 types of bonds. There are the ionic bonds, which are formed from electrostatic attraction between metal cations and non-metal anions. And there are covalent bonds, which are formed from the sharing of electrons between non-metal atoms.